So let me show you one way to approach the Ferris wheel problem. Let's suppose that you are at the start point. Let's say it's the origin. And let's suppose that the wheel has a diameter of 10 feet, right? And let's say that one revolution takes, how about 100 seconds? So going around the world, 100 seconds. What if your friend is up here above you? Then to reach your friend, it would clearly take you 50 seconds, half as long. Let's say that your friend was right there, let's say 5 feet above the ground, like perfectly halfway there. Well, in that case, it would take you, of course, 25 seconds to reach your friend. But what if your friend is at a weird height? Let's suppose your friend is like right there. Let's say your friend is 8 feet above the ground. How long does it take for you to reach your friend? Right there, that's your friend. Well, it's going to take you more than 25, but it's going to take you less than 50 because 25 is there, 50 is there, your friend is somewhere in between. So you know that your time is somewhere between 25 and 50. But we want to be like really exact or more specific at least. So here's what you can do. I would go to the middle, the center of the circle, which is of course at 0.5. Okay. For my example, it's just my own numbers. I would put a point where your friend is, and I would totally draw a hypotenuse or a radius. And I would draw a right triangle. Now, I know for sure that here, that's the hypotenuse or it's the radius, right? This is a radius. This circle has a radius of 5 because if the diameter is 10, then the radius is 5. I know the radius is also the hypotenuse. That's convenient. It's 5. How about this here? Can you tell me what that is? That's going to be 3 because the middle is 5 high. Your friend is 8 high, which means that this here is going to be 3. How about this x coordinate? What does that equal? Go Pythagorean theorem. If you go Pythagorean theorem, you're going to go a squared b squared equals c squared. You will discover that this is 4. Sometimes this will be like a weird square root. If it's like the square root of 31, just leave it like that. My own example happened to work out nicely. So I know that this is 4. Now, why am I even focusing on this triangle? Because this triangle is going to give me that purple angle theta. I can find theta because I know that tangent of theta, tangent is opposite over adjacent. I know that tangent of theta is 3/4, which means that theta equals tangent inverse. My calculator is set to degrees, and it tells me that that purple angle theta is about 36.87 degrees. That there, that's 90. And if you add the 3687, right, if you combine them together, you get this orange. That orange is the same as this purple movement. So look, you know how a full circle is 360, and you know how halfway is 180, and you know how a quarter is 90. Well, from you to your friend, it's 90 plus that. How much is 90? That's 126.87 degrees. I know that 360 degrees is a full spin. And in this problem, one full spin is 100 seconds. So you make a proportion. The key is to make a proportion. 360 degrees is a full circle. Well, 126.87 degrees is to x seconds, where x is the amount of time that it takes for you to reach your friend. If you cross multiply and do your middle school math, time is about 35.24 seconds. And that's appropriate because we said a moment ago to reach your friend, it's more than 25, but it's less than 50.